Good day, sir. I am Naraima M. Manampen, and I am the presenter of this group. I represent about micro hydropower plant MHP design. The member of this group were Cadut Fernando Jose, Deniega Sherwin, Estillore Norin Joyce, yours truly Manampen Naraima, Pulido Angeline, and Simpliciano Sharon. Rational. Electricity is very important nowadays. Electricity is essential part in life of people. People use electricity for lighting, heating, cooking, and other operating appliances like computer and cell phone used in school or online class as a mode in education. It is very important, very efficient energy forms for reducing our workload and making our tasks easier in an increasing demand in energy like electrification. Electrification correlates closely with aspect of sustainable development. To meet the rising demand of electricity, various systems have been created to find solution for alternative energy source like in this paper designed the micro hydropower plant. The micro hydroelectric power is both an efficient and reliable form of clean source of energy. In addition, it can be an excellent method of harnessing renewable energy from small rivers and streams. The micro hydropower project designed to be a runoff river type because it requires very little or no reservoir in order to power the turbine. The water will run straight to the turbine and back into the river or stream to use it for other purposes. This has minimal environmental impact on the local ecosystem. Many rural electrification projects employ micro hydropower plant MHP. The system or installation provide immediate and direct benefit to the local people. Situational assumption. The P demand of this project is equals to 300 kilowatt hour per day. P day is equals to 0.5 P night. Overall efficiency is equals to 50%. Running time is equals to 25 hours a day. QNYER is equals to 1.8 cubic meter per second. Weir intake is equals to 0.6 cubic meter per second. 4 by intake is equals to 45 cubic meter per second. Penstock intake is equals to 0.383 cubic meter per second. For the potential power is equals to 30.03 kilowatts. For the Weir design, overall size is equals to 0.25 factor. For the hindrance design, assumption, Q Weir intake is equal to Q hindrance is equals to 0.3 cubic meter per second. For safety factor is equals to 25%. D adjusted is equals to 0.525 meter. For the base is equals to 0.105 meter. For the 4 by design, the PD is equals to 0.45 meter. Assume Fs is equals to 1.8 meter. Hs is equals to 1.8 D is equals to 0.81 meter. So the S is equals to 2.49 meter. For the penstock design, thicknesses is equals to 2.35 millimeter. For the turbine selection, Q is equals to 0.383 cubic meter per second and HN is equals to 8 meter. SN is equals to 143 meter minus kilowatt hour per cross flow. A cross flow type of turbine, N is equals to 50% efficiency. So the PT is equals to 15.01 kilowatts. So, for generator selection, P generator is equals to PT over 0.8. So, the P gen is equals to 18.7625 QBA. Select up 19 kVA drip proof horizontal shaft synchronous generator with ABRE IC protection relay motor, surges, absorber, space healer, and other control accessories. For the site development plant of this design, it was located in Kabak.
So next is for the site plan. It is located in Kabakan River and we use Google Earth map to locate it. Then for the design components with sketch, powerhouse is located in the left side. Then at the bottom left, we have the generator, then the turbine, and then the tail race, and the inlet valve, then penstock, and in the upper right, we have the weir, the 4-bay tank, and on the bottom right is the trash rack. Next one is for cost analysis. We have the materials, quantity, price in peso, then adjusted price, 20%, then the unit, the size, and the subtotal. For cement, we have 4, quantity is 4, the price is 350, and for 20% of the adjusted price is 420, and it's in kilogram. Then the subtotal for it is 1,680. For gravel, we have quantity is 1, 950 pesos, and adjusted price is 980. Then the subtotal is 980. Rebar is 8 in quantity, then the price is 280. Adjusted price for 20% is 320, then unit is meter, and size is 10. 2,560. As long as the tie wire, we have nails, a lumber, ordinary plywood, and then the sand. So for the subtotal of all of for these materials is 9,470. Materials is 300 kilowatts hydro turbine, welding rod, cement, gravel, rebar, tire wire, nails, lumber, ordinary plywood, and sand. Quantity is for example is for 300 kilowatts hydro turbine, quantity is 1, price is 220,000, adjusted price for 20% is 320,500, then its subtotal is 320,500. For this materials, the overall subtotal price is 329,950 pesos. And for the so the total estimated cost for this is 704,389 pesos, and that's for the cost analysis of the materials to be used for the micro hydropower plant. And for next is for the site development plan. This is different perspectives of site development plan of our micro hydropower plant. So that's the different perspective of it. In the or looking its different direction. Or so for the design summary of MHP, the components are for the weir, we have specifications. It is rectangular weir with height equals 0.61 meters and width is 1.9 meters. The head race is rectangular open channel. Diameter is 0.525 meters, and the base is 0.105 meters. For the forebay, the specifications is square base tank with height of 0.81 meters, and its S equals 2.49 meters. Penstock specifications is steel pipe with D equals 0.47 meters and T equals 2.37 meters. Its flow rate equals 0.383 meter cube per seconds. Its net head is 8 meters. And then the generator is 23 kVA low fuel consuming drip proof. For power transmission, its specification is speed increased V-bolt with opposite pulley. Voltage rating is 220 volts. Frequency is 50 H2. Distribution cable is aluminum feeder with diameter of 0.574 inches and 440 ampacity racing. Distribution transformer is insulated oil immersed type standard core. Then service drop wire is AWG for service aluminum cable, and installation wire is AWG number 12 to 14 DOX type copper. The next is for the summary. A micro hydropower system needs a turbine, pump, or water wheel to transform the energy of flowing water into rotational energy, which is converted into electricity. Micro hydropower plant has been utilized and enable energy source of electricity. The electricity now is the system is used to power a home and community. For our conclusions, hydropower plants are an important source of energy for the world. Water is a fuel that is both efficient and dependable. The use, development, and growth of power plants should be pursued indefinitely. Hydropower, often known as hydroelectric power, is a renewable energy source that creates electricity by altering the natural flow of a river or other body water using a dam or diversion construction. Hydropower facilities can supply critical backup power during significant power outage since their electricity generation is so swift. Hydropower is used to manage flooding, assist with irrigation, and provide water. Hydropower is a cost-effective option. In comparison to the energy sources, hydropower provides low-cost electricity and long-term durability. So for the P demand value, it is equal to 300 kilowatts per hour in a day with power output of the design. Micro hydropower of 30.03 kilowatts. Next is for the recommendations. Identify the amount of consumers design in constructing micro hydropower plant. Then conduct a site assessment and investigation in proposing micro hydropower plant development or necessary to upgrade its level of accuracy. Use effective, efficient, and support and appropriate electricity devices like turbine for MHP. Ensure the micro hydropower plant construction or building process happens at the current time. For the references, we have Science Direct, Science article, https www.sciencedirect.com, hydroelectric, and etc. So here's for our documentation, and all information given above is our own output and definitely not copied from others' work. Thank you.